When people think of the Cold War, they picture rockets, satellites, nuclear weapons. But one of the strangest chapters didn't happen in space. It happened underground. While the United States was racing to plant a flag on the moon, the Soviet Union was drilling straight into the Earth just to see how far they could go. And what they found down there wasn't what anyone expected. They called it the Kola Superdeep Borehole, also known as the Well to Hell. For 20 years, Soviet scientists and engineers pushed deeper and deeper until they broke a world record. They built the deepest hole humans have ever dug, and then without warning, they stopped. So why did they spend decades drilling into the Earth? What did they find down there? And why abandon a project that was once a scientific obsession? Let's find out in this video. The Cold War was not just a political standoff between two superpowers. It was a global contest between two completely different systems, capitalism and communism, each trying to prove it had the better vision for humanity's future. And one of the most visible arenas for that contest was science. After World War II, both the United States and the Soviet Union poured enormous resources into scientific research, not just to gain military advantages, but to demonstrate cultural and technological superiority. This race produced nuclear weapons, intercontinental ballistic missiles, and most famously, the space race. In 1957, the Soviet Union shocked the world by launching Sputnik, the first artificial satellite. It triggered panic in Washington and set off a chain reaction. In just a few years, the Soviets launched Yuri Gagarin, the first human in space. In response, the United States doubled down on its space program. By 1969, America had put Neil Armstrong on the moon. But while the headlines were focused on space, something else was happening beneath the surface. Literally. While above ground, the Americans had claimed the biggest symbolic win with the moon landing in 1969. So the Soviets looked somewhere else to plant their next flag, straight down. Scientists from both sides knew that Earth itself still held huge mysteries. At the time, plate tectonics was still a relatively new theory. No one had ever seen the Earth's mantle up close, let alone reached it. Most of what we knew came from analyzing seismic waves, basically listening to how earthquakes echo through the planet. But that wasn't the same as direct access. If someone could reach the mantle, they might answer some of the biggest geological questions ever asked. That's what led the United States to launch Project Mohole in the late 1950s. Their idea was bold, to drill through the Earth's crust beneath the ocean, where it's thinnest, and reach the boundary between the crust and the mantle, known as the Mohorovičić discontinuity, or MOHO for short. The theory made sense. Oceanic crust is only about 5 to 10 kilometers thick, much thinner than continental crust, which can be up to 70 kilometers thick. In 1961, the Americans began test drilling off the coast of Mexico, but it didn't last long. Costs spiraled, leadership changed hands, and funding was cut. By 1966, Project Mohole was canceled. The deepest they got was just 183 meters, or about 601 feet. To the Soviets, that failure looked like an opportunity. They had already been investing heavily in Earth sciences and had one of the largest geophysical research communities in the world. More importantly, they had something to prove. If the Americans couldn't reach the Moho, maybe the Soviets could go even further, right through the continental crust. It was a scientific mission, but it was also something else. It was a statement. If the Americans were racing to the stars, the Soviets would conquer the Earth from below. So in 1970, Soviet scientists and engineers broke ground on a new project in the Kola Peninsula, a remote, icy region in the far northwest of the USSR, not far from the borders of Norway and Finland. The goal was to reach a depth of 15,000 meters, or just over 9 miles. If they could do it, they wouldn't just beat the Americans, they'd break the world record for the deepest man-made hole ever drilled. The site they chose was deep in the Kola Peninsula, near the Arctic Circle. It wasn't random. This area of continental crust was geologically stable, free from fault lines and major seismic activity. That meant fewer surprises underground. The location was also remote, away from major cities or infrastructure that could interfere with the work or attract too much attention. This was science for science's sake, but make no mistake, this was also about image. If the US had space, the USSR would take what was under our feet. The project started small. In May 1970, Soviet engineers assembled the first drill rig, Uralmash 4E. It was a Soviet-made system originally designed for deep oil wells, but here it was repurposed for a very different challenge. Early drilling went slowly. They worked in phases, drilling few hundred meters, then pausing to analyze rock samples, measure pressure and temperature, and adjust the drilling equipment. Each step gave them new information. The deeper they went, the older the rocks became. Some samples were over 2.5 billion years old, dating back to the early formation of Earth's crust. Eventually, they upgraded the setup to a more advanced rig, Worlmosh 15,000, capable of withstanding more pressure and reaching the full target depth. Even with that, drilling through continental crust was not easy. Unlike ocean crust, which is relatively thin and uniform, continental crust is thicker, more variable, and made of different types of rock. Progress was measured in meters per week, but the slow pace didn't bother them. This was always meant to be a long project. 10, 15, maybe even 20 years. They weren't looking for quick wins. They were after a complete geological record, something no one had ever seen before. Each layer they drilled through told a different story. They logged everything: pressure changes, mineral composition, temperature spikes, fault structures, and each piece of data helped geologists around the world better understand how continents formed and how tectonic plates behave over time. There were challenges, of course. The site was located in a harsh Arctic climate. Winters were brutal, logistics were complicated, teams worked in rotating shifts, and the site needed constant supplies to stay operational. But the Soviet Union treated it like any other mega project, fully funded, heavily staffed, and politically supported. For the USSR, this wasn't just about collecting rock samples. It was about doing what no one else could. It was about being the first to reach a part of the Earth no one had ever physically touched. And as long as the drill kept turning, they were getting closer. However, drilling nearly 15 kilometers into solid rock isn't just a matter of pointing a drill at the ground and hitting go. The deeper you go, the harder everything gets. Literally. The Kola team used rotary drilling, a method where a sharp, rotating drill bit grinds through rock while drilling mud is pumped down to cool the bit and carry debris back to the surface. That system works well for oil wells, which usually reach a few kilometers deep, but the Soviets were trying to go 5 times further. Even in the early stages, equipment failures were common. Drill bits would overheat, pipes would warp, and pressure levels kept climbing. As they got deeper, every mechanical part had to be custom built or redesigned. The deeper they drilled, the stranger it got. At first, scientists expected the data to confirm what they already believed. Instead, it kept breaking their models. One of the biggest surprises came around 7 kilometers down. According to seismic readings, there should have been a solid shift from granite rock to a layer of basalt. That transition zone, commonly assumed to exist in continental crust, just wasn't there. The seismic bounce they had interpreted as a new rock type turned out to be something else entirely. Changes in pressure, not material. This forced geologists to rethink how they interpret seismic data, which is still the primary method for studying the deep Earth today. Then there was the water. At depths of 3 to 6 kilometers, they began finding fluids trapped in the rock. That was unexpected. Conventional thinking said water couldn't exist down there. It should have evaporated long ago or never been present at all. But this wasn't water from the surface. It was chemically bound inside minerals and released as the rock was crushed under pressure. Some of it had likely been there for over 1 billion years. The team also uncovered tiny fossils, microfossils of plankton, embedded in rocks over 2 billion years old. These organisms had been cooked under extreme heat and pressure for geologic ages, yet traces of their structure were still visible under microscopes. These fossils weren't alive, and they weren't found deep in the hole. They were in surface layers just a few kilometers down. But it was still a remarkable find. It showed that life existed in Earth's oceans far earlier than previously thought, and it suggested that even ancient rocks could preserve the fingerprints of living organisms. Temperature was another major problem. Based on seismic data, scientists expected things to be hot, but manageable. The forecast was around 100 degrees Celsius. Instead, by 12 kilometers, it had reached nearly 180 degrees Celsius. Hot enough to make the granite behave less like rock and more like stiff clay. This was a serious problem. It not only damaged equipment, but also meant the rock around the borehole was starting to flow, slowly but constantly, making the hole unstable. They also encountered unexpected fault zones, shifts in rock alignment, and strange acoustic properties. Some layers would dampen sound entirely, while others would transmit it farther than expected. On top of that, the pressure was immense. At 12 kilometers, the weight of the Earth above creates over 1,200 times atmospheric pressure. That pressure tried to close the borehole behind the drill, squeezing in from all directions. To prevent collapse, they had to line the hole with layers of steel casing, but even those casings started to buckle under the strain. As they drilled deeper, progress slowed. Sometimes they'd spend weeks on a single section. The deeper they went, the more equipment had to be hauled back up to the surface for repairs. Each trip taking hours, sometimes days. A mistake at that depth could cost months of work. Despite the problems, they kept going. Soviet engineers upgraded the rig again and again. They brought in new teams. They logged every detail: temperature, pressure, mineral structure. It wasn't fast, but it was thorough. And then, in 1989, nearly 20 years after they started, they broke a world record. They reached a depth of 12,262 meters, about 7.6 miles. That's the deepest point ever drilled by humans, even to this day. They never reached the Moho, but they did something no one else ever had. They opened a physical path through more than 12 kilometers of continental crust. It was a technical achievement, but it also raised new questions about what we thought we knew about the Earth. Every kilometer down added new problems, new mysteries, and new questions. For geologists, this was gold. The data from the borehole led to hundreds of academic papers. It changed how we think about the crust, about how continents form, and about how deep Earth water cycles might work. But for the drilling team, it was frustrating. They weren't just battling engineering problems, they were running into the limits of what their technology could handle. They had gone further than anyone in history, but the Earth wasn't making it easy to go any further. By the early 1990s, the Soviet Union was falling apart. The country was in economic freefall, funding for scientific research had been slashed across the board, and priorities shifted almost overnight. There was no room in the budget for a hole in the ground, no matter how deep it was. In 1992, the Kola Superdeep Borehole was quietly shut down. No ceremony, no announcement. The drilling stopped and the site was left mostly as it was. But the timing raised questions. They had drilled for over 20 years, solving problems that no one else had even attempted. And just as they were approaching the final few kilometers to reach the Moho, the entire project disappeared. That vacuum left space for speculation. In the mid-1990s, a bizarre rumor started spreading. First in European tabloids, then in American radio shows. According to the story, the Soviets had drilled so deep they hit a void underground. They lowered a microphone into the borehole and heard screaming. The legend became known as the Well to Hell. It was completely fake. The audio clip that went viral was lifted from a horror movie. No such microphone existed and no such sounds were ever recorded. Still, the story stuck. You'll still find YouTube videos and Reddit threads asking, did Russia really drill into hell? It's easy to laugh it off, but the rumor said more about the mystery around the project than anything else. The site was remote, the records were mostly in Russian, and after decades of progress, it ended so abruptly with no follow-up, no second attempt, and no real closure. The reality is less dramatic, but just as frustrating. They didn't stop because of what they found. They stopped because the money ran out, the politics changed, and the Earth was simply too hard to beat with the tools they had. Today, if you travel to the Kola Peninsula, there's not much to see. The site of the world's deepest hole sits abandoned in the middle of nowhere. The buildings are falling apart, the equipment is rusted and broken, most of the research staff left decades ago. A few security guards stayed behind for a while, but even they eventually moved on. The borehole itself is covered by a simple metal cap, bolted to a concrete slab. That cap covers more than 12 kilometers of empty space, an invisible shaft deeper than the Mariana Trench, deeper than any mine, deeper than any oil well on Earth. There's nothing to stop someone from walking right up to it. No fence, no warning, just the cold wind and the sound of your own footsteps. For a while, there were rumors that the site would be reopened. That never happened. Eventually, even the building that housed the drill controls was stripped for scrap metal. Today, the entire complex sits empty. You can still find it on satellite images, a grid of decaying structures in the middle of nowhere. Occasionally, researchers or journalists visit the site out of curiosity, but for the most part, it's been forgotten, which makes it even stranger. One of the most ambitious scientific projects ever attempted now looks like a failed construction site. It's easy to look at the Kola Superdeep Borehole and call it a failure. They didn't reach the Moho, they didn't break into some new layer of the Earth, and in the end, they sealed it up and walked away. But what they did accomplish still matters. The data collected from the borehole changed how geologists understand the Earth's crust. It confirmed that seismic readings could be misleading. It proved that ancient water exists miles below the surface. It showed that microscopic life can leave a trace in rocks billions of years old, and it forced researchers to update their models of temperature, pressure, and rock behavior at extreme depths. A lot of what we know about the deep Earth today started with that hole in the ground. More than that, the project showed just how difficult it is to explore what's directly beneath us. We've mapped the moon in more detail than the Earth's interior. We've sent rovers to Mars, but we still haven't reached our own planet's mantle. The Kola project didn't just set a record, it set a benchmark. It proved that ultra-deep drilling was possible, even if progress was slow and the challenges were constant. That inspired other countries to try similar projects of their own. In the 1990s, Germany launched the KTB borehole. Their goal was to reach 10 kilometers into the Earth's crust. The project was located in Bavaria and used more modern equipment than Kola, along with real-time monitoring systems that didn't exist when the Soviets began drilling. German researchers hoped to study seismic activity and the behavior of fluids inside the Earth's crust, especially since the region sits near a known fault zone. They drilled to a final depth of 9,101 meters, or about 5.7 miles. Not quite as deep as Kola, but the project still delivered valuable data on heat flow, fluid migration, and rock mechanics. And just like Kola, they ran into the same barriers: extreme temperatures, mounting pressure, and rising costs. Meanwhile, on the other side of the world, Japan took a different approach. Their Chikyu project, launched in the early 2000s, aimed to reach the mantle by drilling through the ocean floor instead of continental crust. The logic was similar to the original US strategy behind Project Mohole. Oceanic crust is thinner, so reaching the mantle should take less time. The Chikyu vessel itself is one of the most advanced drilling ships ever built. It uses GPS positioning, dynamic thrusters, and a riser system to keep the drill stable in deep water. But even with all that technology, progress has been slow. The deepest point achieved so far is around 3,000 meters below the seafloor, still far from the mantle. In every case, whether it's Germany, Japan, or earlier US attempts, the problems are always the same: extreme heat, constant pressure, and a price tag that keeps growing the deeper you go. And through it all, none of them have gone deeper than the Soviets did in 1989. We've explored space in incredible detail, mapped distant planets, sent probes beyond the solar system, and studied galaxies millions of light years away. But when it comes to our own planet, we've barely made a dent. The deepest hole ever drilled by humans only goes down about 12 kilometers, less than 0.2% of the distance to Earth's core. Exploring Earth's interior is still one of the hardest technical challenges we face. We know more about stars light years away than the rock beneath our feet. Now, here's a question for you. Do you think we'll ever try again? Or did we already go as far as we're meant to? Let us know in the comments below. We would love to hear your thoughts.